Hello, students. Welcome to week 11 of our virtual course. So today we are going to continue our discussion on bivariate associations. Last week we were talking about correlations, which is the assessment of two continuous variables, okay, to produce a Pearson correlation coefficient, which tells you the strength of the relationship and the direction of the relationship, okay? Today, we are going to talk about how to assess categorical variables, okay? The method that is used to do this is called cross-tabulations or crosstabs, okay? Sometimes you will hear them called contingency tables or two-way tables, but these are the same things, okay? So remember, bivariate associations is simply the relationship between two variables, and depending on the type of variable you're looking at, dictates the type of analysis you perform, okay? So when we want to assess two categorical variables, okay, we use a special type of table called a cross-tabulation or a crosstab, okay? Now, when we produce a crosstab, it generates a table that's organized by rows and columns, and each variable is located in either the row or the column, okay? Typically, what we do is we put the independent variable in the column and the dependent variable we place in the row. This is a common method, but you don't necessarily have to do this all the time. In fact, my outlook is that you put the variables in whatever place that makes more sense so that when you produce the table is easiest to read, okay? So different cross tabulations will produce tables of different dimensions, okay? Now the table dimensions are calculated using the R times C, where R is the number of categories in the row variable, and C is the number of categories for the column variable. Now remember, we're talking about categorical variables. So these are variables that have two or more categories within their response categories, okay? Now a standard 2x2 crosstab, okay, looks like this here, okay? A 2x2 crosstab means that you have two variables, okay, and each of those variables has two categories. So one of your variables would be located here, and category 1, category 2. Your second variable would be these columns here, category 1, category 2, okay? Now, let's proceed and move on to what I would characterize as a simple cross-tabulation, okay? Now this cross-tabulation produces a 4x2 crosstab, okay? And it is assessing two variables. One is a class rank of students, so determining their rank in college, either freshman, sophomore, junior, or senior. And the other variable is living, which is asking students, do you live on campus, yes or no, okay? Now, the reason why this is a 4x2 crosstab is because this variable here for the rows has 4 categories, so that's the 4. And then the columns have 2 categories, on campus, off campus. That's where you get the 2 from, okay? Now, if we look at this table, okay, we can look at these numbers here, which are frequencies. So this is just a count, okay, of the number of freshmen off campus, on campus, the number of sophomore off campus, on campus. And then this column here is the totals, okay, of freshmen, sophomore, junior, and senior. And then this row here are the totals of off-campus, on-campus students, okay? Now, when we are trying to make sense of what this table says, we can deduce several main points, okay? Looking at the totals down here, I'm sorry, the totals here on this column, we can see that there are 137 freshmen, 90 sophomores, 98 juniors, and 63 seniors. Okay, that's pretty straightforward. And then if we look at the other totals, we can see that there are a total of 231 people who lived off campus, which is this value here, and 157 who lived on campus. Okay, very simple, very straightforward. We can also look at the number of freshmen, okay, who lived off campus and on campus, and we can see that there are more freshmen who lived on campus, right, 100, than off campus, only 37. And that makes sense because when you're a freshman and you move to college, you more than likely situate in the dorms and whatnot. So that makes sense. Now the next one is looking at the number of sophomores who live on and off campus. We can see that there's roughly equal numbers of sophomores who lived off campus and on campus. Okay, we have 42 and 48. So no major differences there. And when we look at juniors, we can see that there's far more juniors who lived off campus, okay, than on campus. And again, that also makes sense because the older you get, the more likely you are to, you know, get your own apartment and whatnot. And then when we look at seniors, we can see only one senior lived on campus and the rest lived off campus. Okay, very simple. Now, we can do the same thing with these variables, but produce a different contingency table, okay, that produces row percentages, okay. Now, one of the things that you can do when you are assessing data is you can sort of change the categories and simplify them, okay. So this crosstab here is building off of the previous one, okay. The 4 category variable where it was freshman, sophomore, junior, senior has now been updated to a 2 category version, and it's simply upperclassmen and underclassmen, okay, and we still have the same on-campus, off-campus variable, okay. So when we look at this table, there are a couple of points that are noteworthy that we can look at. Okay, the row percents, okay, which are these here, they tell us the percentages of upper or underclassmen who live on campus or off campus, okay. We can see here, based on the percentages, okay, that the proportion of underclassmen who live off campus is 34.8%. okay, or 79 individuals out of the 227 total, okay. If we look at the number of underclassmen who live on campus, we derive a percentage of 65.2%, okay, which is derived from the 148 over the total number, okay. This actually should say 227, okay. We can do the same thing for upperclassmen who live off campus, which is 94.4%, and upperclassmen who live on campus, which is 5.6%, okay? Simple stuff. Now, another thing we can do with the crosstab is we can add what we call a layer variable, okay? So this is the same these are the same variables here, okay, but we are adding on top of that another variable and we're layering it, okay. So in this instance, we are accounting for the state of residence as a layer. Okay, now when you add this layer variable, you'll notice that the total number of valid cases that are produced in your table drops. This is totally normal, since what it's doing is that it's calculating all of the valid cases across all three variables. And so respondents have to have answered to all three variables to be included. Okay. So this cross tabulation here is looking at college rank by living status within levels of state. Okay. From here, we can deduce 4 simple points. Okay. There are more of out-of-state underclassmen, okay, out-of-state underclassmen who live on campus, okay, than those who are in-state on campus, okay. So if we are looking at the total number of underclassmen living on campus out of state. Now, I had to pause and proceed because I almost confused myself. Now, the reason why this is saying there's more out-of-state underclassmen, right, when there's 30, than in-state underclassmen, it's sort of like, wait, there's 110 in-state and only 30 out of state. So how can it be more? The reason why is because these are frequencies only. You're trying to derive the percentage within each group. So if you divide 30 out of a total of 43, you get a proportion that is about, I think, 69%. If you divide 110 from the total 168, it's something like 64%. So we are deriving the percentages or the proportions within each group, okay? When we are looking at out-of-state individuals by class, we can see that there's roughly equal numbers, okay? Upperclassmen and underclassmen. When we are looking at in-state students, okay, underclassmen outnumber upperclassmen. Okay, we can see this in the totals derived on the rows. Okay, and then finally, of the 9 upperclassmen who are living on campus, 2 were out of state. So on campus, upperclassmen, out of state, there's 2 of them here. Okay, simple stuff. So I am going to continue on to the part 2 of the week 11 handouts. Okay, this is also on Blackboard for you to access. Now, this is going to cover a continuation of bivariate associations and also the assessment of categorical variables. But we are going to learn about a test that is called Chi-square, okay? And it is used for categorical variables being assessed together, okay? Now, a Chi-square test is produced very similar to a crosstab. All you do is you specify to SPSS that you want the test to be performed on that crosstab, okay? So let's discuss what exactly a chi-square test is. Now, it's called a chi-square test. Oops, wrong one. It's called a chi-square test of independence because it is looking at the different categories of each variable, and it's looking at whether or not there is a true association between these categorical variables. Now, remember, when we are running a crosstab, okay, like this, all we are doing is we are looking at the breakdown of categories and the frequencies and percentages, okay? This is just giving us numbers. this doesn't tell us whether or not there is a true relationship between the two variables, so that if you were to observe this in real life, if these findings would stand. Okay, that's what a chi-square test does, is it runs the crosstab, but then it tests to see if there is a true relationship between the categories of those variables. Okay, now the test utilizes a contingency table, which is a crosstab. Okay, and it arranges the data in the same way as we learned before. Okay. All right, let me see. So what I want you to remember about the chi-square test of independence is that it can only compare categorical variables that have two or more categories. Okay, that is all a chi-square test can assess. It does not make comparisons between other types of variables. Okay, and most importantly, something that I want you to remember is that when we are assessing bivariate associations, and that includes crosstabs and chi-square test, we are only looking at associations, relationships. Okay, what we see here, the results that we are looking at, do not say anything about causation. We are not saying that one thing causes the other. All we are saying is that there is a relationship between those two variables. Okay. All right. So here's an example. Okay, let's say we run a cross tabulation. Okay, looking at the relationship between smoking behavior and gender. Okay, smoking behavior has three categories: non-smoker, past smoker, and current smoker. Okay, and then of course the gender has two categories: male and female. All right. So when we run this crosstab, we are going to specify the chi-square test of independence, and I'll show you how to do this when we're covering the SPSS lecture. Okay, and we will set a level of significance that we want the test to pass. Okay, the standards by which we want the test to pass. I usually set it at 0.10. Okay, so when you run this, you're going to get an output. Okay, you're going to get this normal crosstab right here, and then below you are going to get the chi-square test. Okay, now what's important to look at, okay, is this value here, the Pearson chi-square. Okay, we want to get the value. Oops, we want to get the value. Okay, and then we want to get the significance, okay, or the p-value, which is this column here. Okay. All right. So we look at this output here, all right, and we can see several things. Okay. First of all, the results for this chi-square test that's looking at these variables shows a value of 3.171. This is the chi-square value. Okay. Now its p-value, oh no, sorry guys, its p-value is on this column here. Okay, and it is p equals 0.205. Now, if you remember what we learned when we were covering significance, this is not significant. Okay, so this does not meet our standards for significance. Okay, it is less than our set level of significance. Okay, oh, I just saw a typo, guys. So this is supposed to say, right, there is no significant association between gender and smoking. Okay, because this chi-square value is not statistically significant. So while we are looking at the breakdown of male and female and smoking habits, there is not really anything to this relationship. It's not statistically significant. It's not something that can be visualized in real life empirically, okay? At the end of the statement, you want to include your chi-square value and then your p-value, okay, in parentheses. All right. So again, this is saying there is no significant association between gender and smoking. Okay. All righty. And that is it for handout lectures. I'm going to post a follow-up video that shows the SPSS instructions on how to derive cross tabulations and then chi-square tests for independence. All right. Thank you, guys.